Hello students. Today we're going to look at section 8.3, which is a continuation of exponents, but today we're going to talk about negative exponents and the exponent of 0. A lot of you have had questions about negative exponents, so your answers are going to come today. The first thing though we're going to start with is the 0 exponent, because the 0 exponent is just really not hard to deal with. So any number or variable to the 0 power equals 1. That's all you need to know. 6 to the 0 power equals 1. 537 to the 0 power equals 1. X to the 0 power equals 1. Any number raised to the 0 power equals 1. Period. End of sentence. That's all you need to know. It's raised to the 0 power, it equals 1. That's all for that part. So now draw kind of a squiggly line to separate the stuff that we're doing next, and that is negative exponents. So let's talk about a negative exponent. Let's say we have a to the negative n power. We can say that that is a reciprocal, spell that wrong, reciprocal of a to the n, so it equals 1 over a to the n. So let me try to sum this up in a few words that make sense. Any number to a negative exponent, you make the reciprocal. So a to the negative n power equals 1 over a to the n. A to the negative third power equals 1 over a to the third. 7 to the negative third power equals 1 over 7 to the third power. 2x to the negative fourth power. Notice that 2 does not have an exponent. 2's exponent is 1. The negative exponent is only on the x. So 2 stays exactly where it is. So this equals 2 over x to the fourth. One way people like to think of it is any number with a negative exponent switches place in the fraction. So if it's in the numerator with a negative exponent, we move it to the denominator to make a positive exponent. If it's in the denominator with a negative exponent, we move it to the numerator to make it a positive exponent. I'm going to erase this and we're going to do a couple more examples. What if I have 1 over b to the negative third power? Well, since b with the negative third power is in the denominator, to make my exponent positive, I move it to the numerator, so this equals b to the third power. Flip it, make the reciprocal. What if I have 2x in parentheses to the negative second power? The first thing I need to do is to create a positive exponent, so this would be 1 over 2x to the second. And then I would keep going and follow my rules about power of a product, and that would be 1 over 4x squared, because 2 squared is 4 and x squared is x squared. Now let me just dispel one thing. A negative exponent does not mean my base is negative. They have absolutely nothing to do with each other. The negative exponent just tells me that I'm moving it to the denominator to make it a positive exponent, or moving it to the numerator to make it a positive exponent. Now let's do a couple of other examples that bring in some craziness. Let's say we have 1/5 to the negative second power. Well, the negative second power, I need to get this to be a positive exponent, so I'm going to do the reciprocal of 1/5. So that's going to be 5 over 1 to the second power. Now I can apply that second power to everything, and that's just going to equal 25 over 1, which equals 25. Now here's where it kind of gets really confusing. You're going to have negative 8 to the negative second power. Remember that the negative on this base has nothing to do with the negative on that exponent. This is going to stay negative 8. But to get rid of the negative exponent to make it positive, I have to flip this. So this is going to be 1 over negative 8 to the second. Now my exponent is positive because I did the reciprocal. And that equals 1 over 64. What about this one? 5 to the negative 1 over 5 to the second. Now there are two things that I could do on this one. You know that when we're dividing the same exponent, when we're dividing the same base, we subtract the exponents. So negative 1 minus 2 is negative 3. So this would be 5 to the negative third power. But I can't keep it like that because I want my exponent to be positive. So instead of 5 to the third power, now I do 1 over 5 to the third, and that equals 1 over 125. So just again, going back to clarify, I'm using my exponent with quotients property that when I'm dividing the same base, I subtract the exponent. Negative 1 minus 2 is negative 3. And then I flip that to make the reciprocal to make 1 over 5 to the third. And the last example I want to do for you is 2x to the negative third y squared divided by 8x to the fifth y. So let's start with our 2 and our 8. We'll start with 2 and our 8, and we're just going to simplify. That's going to become a 1. That's going to become a 4. So 1/4. Now I've got x to the negative third over x to the fifth. So the way I can look at this two ways. I can take the x to the third and move it down to the denominator. And when I move it down to the denominator, I've got x to the fifth times x to the third, which gives me x to the eighth in the denominator. So I have 4x to the eighth. And I've got y squared over y. So I subtract those two, and I'm left with y to the first power, so y stays on top. So this 2x to the negative third y squared over 8x to the fifth y simplifies to y over 4x to the eighth power. Here are the 4 practice problems that I would like for you to complete. And notice the instructions say write all answers with positive exponents. So we're going to be simplifying and you're going to be using powers, but everything needs to have a positive exponent. So the first one is, in parentheses, 4g raised to the negative third power, 2y to the negative third power. Notice the 2 has an exponent of 1. Y is the only thing with the negative power. Over here, x squared y to the negative third. And then d is 3xy to the negative third over 9x to the third y. Do those practice problems, simplify them to positive exponents, and then take a picture and submit it through Edmodo.